Hello everybody, welcome. In today's video I'm going to explain the science behind Lamine Yamal's amazing goal against France in the Euro semi-final. Unfortunately I can't show you the goal in this video because I get copyright claimed. The video would be deleted, nobody would watch it. So if you want to watch the goal and like kind of understand it better, because you can see how the ball is rotating and where it curves and such, you can watch like the highlights of the game. But I'm going to assume you already know how the goal is. Basically, Yamal hits the ball towards the left side like this and imparts a spin in the clockwise direction on the ball. If you're confused why it's clockwise, imagine a clock like this. I can't draw a clock, but just imagine a clock. Say this is 12 o'clock, 1 o'clock, 2 o'clock, 3 o'clock, 4 o'clock, and 6 o'clock. You can see here that the rotation of this ball is the same as the rotation of our hand would move in a clock. So that's why we call it clockwise rotation. Anti-clockwise would be the exact opposite. Go from 12-hour clock to 11 to 10 to 9 to 8. So now the thing is, the rotation of the ball is very important, and it's the thing that causes it to curve in the first place. As you can see here, incoming air arriving on the ball while it's rotating will cause a certain types of effects. And the reason why the incoming air is in this direction as opposed to this direction is because the ball is moving forwards. So when the ball is moving forwards and is being hit by this incoming air on the right side of the ball gets rotated alongside the ball, so it gets moved due to the rotation of the ball. As you can see here, the arrow will kind of be deflected towards the left. It will kind of be rotated towards the left. But air on the left side of the ball will be slowed down because the rotation of the ball is opposing the motion of that incoming air, causing the air on the left side to slow down. And because it's slowed down, there will be more air on the left side as opposed to the right side, because the right side, the speed hasn't changed, just the direction has been deflected towards the left. So you can see here there will be a buildup of air. It will be important. This will be important later on. However, I'll focus on why the air on the right side being deflected to the left is very important. The reason why is because the air being on the right side, when it leaves, it will be deflected to the left, meaning that something moved it to the left, and that's obviously the ball. So the ball therefore has to move to the right. How? Well, this is just Newton's third law. And you can kind of think of, say, a rocket. I know this is an amazing drawing of a rocket. As it shoots the air exhaust downwards, as rockets do, you can see here that the air is moving down. There's a force pushing the air downwards, causing an equal and opposite force upwards. Since it's equal and opposite, I should draw the arrows roughly the same length. And this is basically the exact same thing. The air moves to the left, so the ball has to move to the right. Now remember, these are forces, not really speeds. Force causes a change in velocity, in speed. Cause acceleration, basically. So the ball can still move towards the left, but eventually it will have to move to the right due to this acceleration. Now the buildup of air that I talked about earlier, due to the air on the left side being slowed down, this will mean that there will be increased pressure because there's more air molecules on the left, so they'll hit the ball more, causing a net motion to the right. So all of this causes a net rotation of the ball to the right. So you can have this force to the right. I'll call it Fm, and the M here is for the Magnus effect. I'll write it better. This entire phenomenon is known as the Magnus effect. It's used in every sport with a ball: tennis, cricket, golf, any sport, even volleyball. Any sport where you have a ball, this effect is applicable because you can curve the ball in a certain way and it will move in certain directions. The most applicable sport, in my opinion, is football, because really anything is possible. Like, you can hit it curved, and this effect will play a part in how it curves. And you can also put no spin at all. So instead of hitting it to the side, you can hit it right at the center and do what is known as a knuckleball. You obviously know what a knuckleball is, and you'll know that a knuckleball is really what's the word? Unpredictable. And the reason why it's unpredictable is for another video. If you want to know why the knuckleball is unpredictable, I'll leave a link down in the description below about the science behind knuckleballs. But it's basically, I'll give you a rundown. It's basically like air currents going on both sides of the ball, on the top and the bottom, are turbulent. So this causes the unpredictability. Anyway, that's why curveballs exist. Hope you enjoyed the video, and bye bye.